So, talk to me about drawing an atom out. Let's do this one real quick. Make it real quick. Nitrogen, right? My favorite atom, nitrogen. How many atomic number? Number of atomic mass. 14. Protons? 7. How do I know the number of protons? Corbin? Not my protons. How do I find protons, Scotty?
Protons is always the atomic number.
Protons is always equal to the atomic number. What is my number of neutrons? Corbin?
7.
Which will give me 7. My electrons equals the number of protons, which for this case
7.
is 7. If it's an electrically neutral atom, we'll start getting into today about the non-electrically neutral, because we're going to start talking about ionic and covalent bonds and why we're bonding and stuff like that. Okay, so we're going to draw it out. My nucleus contains what? JJ, what goes in my nucleus? I know you know it. Protons and neutrons. How many protons? 7. How many neutrons? 7. First energy level. How many trailer park girls go around the outside? Around the outside. Leandra, 2. How many will fit in that first energy level?
2.
2. 2 is the max. Will I fill it up?
Yes, you will.
So 2 electrons will fill that up. How many total electrons do I have left, Kendrick? I got 5, right? How many go in that second energy level? What's the max?
8.
8's the max. Justin, can I put 8 into there? Yes. How many do I have to put in? 5. Will all 5 fit?
Yes.
Do I need to go to another energy level?
No.
No. Is it possible that these electrons will jump to another energy level?
Yes.
Because those energy levels exist for these electrons. Remember that video that they said? There's a possibility that one of these electrons could be on the other side of the known universe. And they come right back because they're flying all over the place. So is it possible that the electrons get excited and jump out of these energy levels? Yes, but we're going to draw them at their lowest lazy state. Everybody wants to be lazy, so we're going to put them in their lazy state. Right? Now, nitrogen. What is that number that I just boxed up? Do you know what the name of that is, Matthew? Number that I just put in a box. What is that word?
The valence electron.
And what do we know about valence electrons? They're the outermost. Why are they important?
They determine the bond.
They determine the bonds. Eric and I. Eric's my best friend.
Aw.
Yeah, I know, right? Who's playing? Oh, he's building atoms. I thought he was playing, but he's building atoms. So Eric and I are best friends. We bond together, right? We got a bromance going on. With my bromance, does my heart ever come in contact with his heart?
No.
Does anything on the inside of my innards, my liver, my intestine, ever touch a part of Eric's body?
No.
No. So will the nucleuses of any atom ever actually touch the nucleus of another atom? No. So when one atom gets close to another atom, what is going to be the part that touches? The outermost, right? Eric, when we go to do our little fist bump or our handshake, what actually is being connected right here? My skin, right? The outermost layer of me is the only thing that's coming in contact with each other. Are you kind of following what I'm trying to do with my little handshake?
Yes.
My skin is the only thing coming in contact with Eric's skin. So the outermost layer of me is touching the outermost layer of Eric. How does that connect to electrons, and how does that connect to atoms?
It's outermost.
Because the valence electrons are the only things they're going to touch. When they touch, they stick, bounce off, they do other crazy things, but that's where the bonding comes from. The number of valence electrons controls the types of bonds you can make. Second piece, nitrogen. What vertical column is it in on that periodic table?
The 5th.
It's in the 15, right? So most periodic tables that you look at will count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. In this class, the majority of the elements that we talk about do not fall in that middle 10. Right? So I call them the spires, the twin towers. You have the towers on the left-hand side, which is columns 1 and 2. And then you have the tower on the right-hand side, which is columns 13, 14, 15, 16, 17, 18, 19, 18. Do you see what I'm talking about by the twin towers?
3 through 12.
3 through
You see?
no 3 through 12 are nothing for us. They don't follow my pattern, right? So when you get to 13, just subtract 10, and that'll work with my pattern. Because what pattern am I trying to show you? How many valence electrons does nitrogen have? It's up on the board. How many valence electrons?
The 5.
5. What vertical column is nitrogen in?
The 15th. But it's 5. It's 5.
The 15th. What do we do with 15? Take away the 10. How many valence electrons does nitrogen have?
5.
What column's it in?
5.
Coincidence! I know I did that last week. Whatever. Is there a coincidence to that? No. The dude, Mendeleev, who built this, was a freaking genius. Right? Because he built this in the 1800s, knowing that these trends and patterns existed. And we can't even, I'm just going to say wipe our own butts, but I was trying to think of another, like, what are things that we fail at as a human society? We can't even walk down the road without walking into things because we're playing Pokemon Go. And this dude, for fun, created the periodic table. With all of these trends, so he built it. So how many valence electrons does nitrogen have?
5.
5. How many, using that principle, find carbon on your periodic table. How many valence electrons do you believe carbon to have, Nick? How many valence electrons will carbon have?
This one.
4? Carbon? What column's it in? Huh? It is not in 14. Is it? You're right. You're right. Because it's element number 6. 2 go in the first, 4 go in the second. Nick, you are correct. Dikeman stands corrected. I apologize. My bad. Neon. How many valence electrons do you expect neon to have? 8. What did I tell you yesterday? What is everybody trying to get to? What's my magic number?
8.
8 is my magic number. Because 8 means it's stable. 8 means it's full. Every atom wants to be full. Every atom wants to be stable. Is nitrogen stable the way that it is right now? Is nitrogen drawn on the board stable?
Yeah. Yes.
Matthew says no. Why you say no? You shook your head no. Why is it not stable for anybody that believes it's not? Because it is not.
There's 3 empty spaces.
Because there's 3 empty electrons. It still needs 3 more. It can kick 5 out or bring 3 in, but it still needs more. All right, so I want to start drawing and taking this and elevating it to something called a Lewis dot diagram. Anybody make these in chemistry last year?
I did.
I like them because basically it's the shortcut way of doing this. I don't have to worry about the protons and neutrons anymore. All I care about is one number. What number is that? The valence electron. So nitrogen, if I'm drawing nitrogen's Lewis dot diagram, remember, if I'm writing things on the board, it's not to work on my biceps, triceps, and deltoids. I'm already dead sexy. Because I think you need to write it down. For me, writing things down helps. So, and I'm going to kind of draw this as a box. And I'm probably going to describe this in such a way that's very different from the other teachers that you had. Describe it.
Yes.
A Lewis dot diagram is a diagram that shows electrons and essentially their positions around the atom. The way I look at it is, the symbol for the atom is like a campfire. You guys ever go to a campfire?
Oh, yeah.
And you got logs sitting around the campfire. How many people can sit on a log?
2.
There's 2. So there's 2 people sitting on a log, and how many different positions are there around the log?
There's 4.
There's 4, north, south, east, west, right? So you have a north, you have a south, you have an east, and a west. And there's 2 people per log. Right? Because that makes a total of how many electrons? 8. And now I just go about filling in my dots. But here's, which represent my electrons. Here's the fun thing, fun fact. How many do I need to put in for nitrogen? How many electrons do I need to put in here in my dot diagram? How many dots do I need?
5.
I need 5 because all I care about is the valence, not 7. I need 5. Put my first dot on top. Okay. Electrons have what kind of charge? They have a negative charge. So if I put 2 electrons together, what happens when you take magnets of the same type? They go away from each other. I like to refer to this as the urinal rule. Guys, when you go to the bathroom, there's a stall of, let's go 5 urinals. Do you ever go to the one right next to the guy that's already going?
No way, dude.
No, there's the one urinal buffer. Here's another one. Here's another example of this. You go to the movie theater, and you go with a buddy. I just did this last weekend to watch Suicide Squad. You and your buddy, 2 guys, go to the movie theater. Do you sit down in seats right next to each other?
Oh, no.
I mean,
it wouldn't really matter.
Would you ever sit, unless you are forced to, if you are in an empty theater, you would sit how far away?
At least a seat.
You're gonna do 2 seats? Nah, dude, it's a 1-seat buffer. Everybody sits 1 seat away because they want both armrests, is what they say, but they just don't want to sit too close, right? Unless they're forced to. Here's an example for girls. Girls, they sit right next to each other. They don't follow that rule. However, if you go in with your group of girls, Lizzie, you got a group of 5 girls going to watch, I don't know, Bad Moms. You're going to watch Bad Moms. Group of 5 girls. When you go into the theater, do you sit right next to the next group in that aisle? Right? How much do you give yourself? Usually at least 1 seat, right? You don't want to sit next to each other. So the whole point of talking about this. Oh, and I used the urinal example, and I usually don't bring up the girls. About 2 years ago I did, and the girls were like, yeah, I'm not going to use the stall next to somebody that's already using it. You got to go at least 1 stall down. That was the first time I ever heard a girl tell me that, which I just thought was funny. So, am I going to put my next electron, which I put 1 on the north, am I going to put 1, where am I going to put my next one? Am I going to put it on the same bench or the same stool? You say south? Okay, I'll go south. I put in 2, how many are left?
3.
3 left. So I'm going to go, I'll go east, and I'll go west. Uh-oh, I'm hitting a dilemma. I was told, and I told you, that they don't want to be next to each other. But is there a choice?
no.
No, there's no choice. So it's got to pair up with somebody. I usually always pair it up at the top. I always kind of go clockwise around when I do it. So that's nitrogen. And if I would remove these, because you don't want to draw the boxes in, because all we're looking for, it's not called a dot box diagram. It's called a Lewis dot diagram. Because all we're looking for is a way to depict the number of valence electrons. So there you go. You got nitrogen. So the most common earth elements: silicon, oxygen, sodium, magnesium, calcium, we'll go fluorine, and chlorine. 1, 2, 3, 4, 5, 6, 7. I want you to draw out the Lewis dot diagrams.